carrying on with simultaneous equations, but we're going to move on to substitution methods. I've written here that substitution is when you replace a term with another term of equal value. So what we're saying is that it might be different, but it's got the same value. So if I replace a part of an equation with something different but with equal value, I've not affected the value of the equation. Okay, so it's a very commonly used thing in maths. What I would like to do is just show you this. We're going to have a look at the method that we've already had a look at of equating the two sides. But just to actually discuss and say it's pretty much the same thing as what we're going to look onto. Alright, so I've got these two equations that I want to find the simultaneous solution. So could you just recap for me what we mean by finding the simultaneous solution or solve the simultaneous equation? What are we actually meaning by that? Find what x and y is, but in what sense? Right? So where lines cross, okay, but that has a significance as well. You say find coordinates, find the x and y, but what specifically about the x and y?
Where they cross the axis.
Well, we're only interested in that if that's where the lines cross, actually. So remember, seeing where the graphs cross is one way of finding the solution. Another way was making one side equal to the other and solving it. But what I'm getting at is you end up with an x equals something and a y equals something. But what's the significance of that? Pardon? I can't hear you.
Same value.
The same value. What do you mean by the same value? X and y, or? So x and y will be the same, but we've got two equations here, number 1 and number 2. If I find one x value and one y value, what I'm basically saying is that x value, if I put it into both equations, I will get the same y value out. Okay? Do you remember I drew that little flow diagram that says you start with one particular value of x, and normally if you stick it into a function, all right, that function will give you a y value, and if you stick it into a different function, normally you will get a different y value. Remember that diagram? So when we have simultaneous solutions, what does that actually mean? Pardon? My hearing is gone after I can't hear genuinely. Someone said, if we're looking at simultaneous equations, the same x goes still into two different ones, so function 1 and function 2, but instead of, it'll be the same y. So what comes out will be the same value of y. So this will be what we think of as the simultaneous solution. Okay? So that means that for one particular value of x, there will be one value of y that comes out with both functions. All right? And that's what we're looking for. Now, what that looks like is where the lines cross, because they share that coordinate. But we looked at y is because the line is just all the points that go into the function and the answer comes out. Okay? That makes sense, just to remind you what we're actually looking for in the simultaneous equations. So, assuming we're not going to draw the graph or do it on our calculator at the moment, we're just going to use our algebraic approach. Do you remember how to go about doing this just by equating the same sides and why you're allowed to do it? Yeah. What does that mean?
So when you do the x plus 4 equals 5
I
minus
say, so we can make the statement that x plus 4 is equal to 5 minus x. Why am I allowed to say that?
because both x's are equal.
Say it again, sorry.
Both y's are the same in the equation.
Yeah, so we're saying we're looking for when the x's are the same, the y's are the same, therefore y equals and y equals. If we're saying that the y's are the same value, then we can make the statement that therefore x plus 4 must be the same value as 5 minus x. Okay? So we can write, really what I could write is y is equal to x plus 4, which is equal to 5 minus x. We don't need to write this y equals, so we just look at the x plus 4 equals 5 minus x and see what we can do with it. Okay? Now, another way to look at that, if you like, is to say, well, if y equals x plus 4 and this is a y, what if I just replace that y with the x plus 4? Yeah? So that would be what we're going to be talking about, which is the substitution method. So you replace the y with something you know is the same value as y. Does that make sense? Okay. In this case, we don't necessarily need to think of it like that. But what happens when we change the form of the equation that we're using? So that's what we'll get into look at. Well, let's just finish this one off. So we've made one side equal to the other. I'm just going to get rid of that. What's x plus 4 equals 5 minus x? How do we find x now?
Add x on both sides.
Okay, so I'm going to add x there. I'm going to add it there. So that gives me
2x
2x plus
4 equals 5.
Good.
And then minus 4 from both sides.
Yeah, minus 4 gives me,
2x equals 1. And then x equals 1 over 2.
so I divide by 2. So I get x equals 1 over 2. How do I find y?
Put that into the equation.
Yeah, either one, because y can be found by doing either one. So y equals x plus 4. So we'll use number 1. I could do the same with number 2. But if we say x is a half, so y is a half plus 4. So remember we had this discussion that is just 4 and a half. Nice and easy. Okay. Okay. Now what you'll notice about those ones that you've just been doing, all of them are basically y equals. Okay, so therefore another one could be y equals x minus 4 and y equals minus 2x minus 4. Okay, but you can see it's y equals both times. It makes it nice and simple. By the way, anyone remember and tell me the answer to that one like that?
Yeah.
And
Y is minus 4.
because?
Because it's the y-intercept.
That's what you're going to say as well, yeah? Yeah. Because
Oh, good job.
minus 4 is the y-intercept, so we know that the y-intercept is minus 4 for both of those. Okay? Therefore, that's where they have to cross. And therefore, the y-intercept has x coordinate 0. So we can actually look at that one and say x equals 0, y equals minus 4 straight away. Let's move on to the next section now, where we change things up a little bit. So you're very used to seeing equations in different form now. So what if we have y equals 3 plus x, and then 5x minus 2y equals 0. So we've got it. We've got the y equals mx plus c form, and we've got the general form of the equation.
Would be rearranged.
You could rearrange. That would be one way to do it. Okay. rearrange and carry on with what you were doing. Not a problem, actually. But what we'll have a look at is we'll carry on this substitution idea, and we'll ask the question that, well, does it matter where the y is?
Because you can just rearrange the bottom.
You can rearrange or just substitute as is. So the statement that has been made, the nice and easy one, is this one here, is y. Anything y could be replaced with 3 plus x. Does that make sense? This one is a bit like, well, that is all equal to 0. There's nothing really helpful to go. But this one definitely, well, the y is equal to 3 plus x. So what I can do is in the second one, why not replace the y with 3 plus x? It's really the same principle. We know that y is the same in both. So instead of rearranging first, let's just chuck it straight in. So I'm going to replace y with 3 plus x. Okay, so that goes in there. So we end up with 5x still minus 2 lots of y. So that must be 2 lots of 3 plus x. That has to equal 0.
And you would just expand the bracket in.
Yeah. Now we just use whatever method we've got for expanding, simplifying, that kind of thing. So 5x, well, it's minus 2 times,
Minus 2x.
so it's minus 2x, yeah. Because it's minus 2 times positive x. Okay, so we've got it's minus 2x, that equals 0. So collect like terms, good. So we've got like terms, 5x and minus 2x. So 3x minus 6 is 0.
Oh, gotcha.
Could you move the 6 to the 0?
Oh.
Stop using
Could you add 6 to both sides?
Yes, we could definitely add 6 to both sides. I'd love to add 6 to both sides.
So 3x.
So 3x equals,
And then x equals 2.
divided by 3, gives me x equals 2. So then again, back to the initial 2, chuck one in. I might as well just use y equals 3 plus x. Therefore, y is 3 plus 2, which is 5.
How fabulous.
Yeah? So don't forget to make it clear where your solutions are.
Okay, is it possible to break this down?
Feel free. Okay, so to start with, these ones that would be considered easier, it's very clear which one you're going to substitute into which one. Okay. Now, what I want to do before I go through the answer to this one, I just want to show you what happens if you substitute the same one. So substitute the value into the same equation, if you know what I mean. So for instance, I know that y equals, actually it doesn't really work in this case. Let's try rearranging this. Let's say we want to rearrange it to make this one y equals. So remember we suggested we could rearrange and have them both y equals. So let's have a look. What happens if you rearrange number 2 this time? So rearrange this to make it y equals for me. What do we have? Sorry, say that again. So I'm going to do 5x minus 2y equals 8. What would you do first? We can't divide by negative 2 yet.
No, subtract 5x.
So I'm going to subtract in 5x first. Gives me minus 2y equals 8 minus 5x. Divide by negative 2. So I get y equals 8 minus 5x all over negative 2. Okay, so now I've got another one. Now, this is a mistake some people would then do. They would then take this, right? So they've just done a rearrangement. They've got a y equals, and then they would replace this y here with that.
Oh, yeah.
It's fine. Well, let's see what happens if you do. So I'm going to replace this y here with everything here, which in itself seems all right, because I've told you y equals that. So it should make sense to do it, yeah? It's fine. Should be fine. Well, let's just check. So 5x minus 2 lots of 8 minus 5x all over minus 2. And that equals 8. Now, it looks a bit complicated, but that's not a problem. Okay? So let's expand this. So we've got 5x. What's minus 2 times all of this over minus 2?
Oh,
No,
that was just
five
passing
minus
down
my
the
life.
8 minus 5.
So it's just
Stop stealing my partner from me.
8 minus 5x.
Oh, I'm confused how you forgot all.
Because multiply by 2 and divide by 2 just cancel each other.
Oh, yeah.
Automatic. Yeah.
Right. Let's have a look at what that then does. Is 5x minus 5x is nothing. So I get left with 8 equals 8. Brilliant. Well, that's true, isn't it? Yeah. 8 equals 8. Yeah, we're very happy that we've got a correct statement. No problems there. It doesn't help me. It doesn't tell me what x is or y is, but we have proven beyond all doubt that 8 is equal to 8. It's good.
Why did you do that? Oh, never mind.
Can't you just minus this from both sides?
Now,
So x is 0?
Well, no, let's just say there's no mistake in what we just did there. This answer is true. What happened though is you've substituted back into the same equation. Right? If you rearrange and substitute, right, you have to substitute into the second. Now, to do simultaneous solutions, you need 2 equations to be able to find the answers out. So if you only ever use 1, you're not going to actually get the solution. You need 2. So in this case, the problem has come about that people rearrange, think, oh yeah, you've got that, but then because of where they are in their thinking and the mess that's on the page, the amount of work, they just substitute into the wrong one. So you'll see that if you end up with something like 8 equals 8, first thought is, did I substitute into the wrong one? Okay. So this should actually be substituted in up here. Right? So what I should be doing, or
Is that a way of checking your answers?
what do you mean?
Yeah,
You know you've done the wrong thing.
but you check that your y is correct.
Oh, okay, your rearrangement. Yeah, I guess if you ended up with 8 equals 6, you would have done something wrong. Yeah. Now at this stage, I could easily now, instead of substituting into here, I could replace this. That's what I would need to do. And say, right, 8 minus 5x all over negative 2 is actually equal to 5 minus 2x. That would have been the right thing to do. But actually, in this case, I didn't need to do any rearrangement, did I? To start with, what we would actually have preferred to do, rather than have that complicated fraction and all that, we should have just replaced this y here, so with this, into that one. Okay? Which is what I'm sure you all did. So then we end up with 5x minus 2 times 5 minus 2x equals 8. Okay. So then we multiply out. So we've got 5x equals, sorry, not 5x equals, 5x minus 10 plus 4x is 8. You all happy with that? The plus 4x? Anyone not? Anyone wants to ask that? No. Minus 2 times 5 is the minus 10. Minus 2 times minus 2x, positive 4x. Okay. Collect like terms. So 5x plus 4x is
9x.
So we've got 9x minus 10. So we carry on. Plus 10.
On both
That's
sides.
why I read wrong. Why would it mess up that?
Oh yeah, and that means x equals 2.
Oh, because you're trying to go. Okay, I got it.
Okay.
I'm good.
So what I would like to do now, just moving on to
G's out.
question 2. Basically, do you remember we've talked about this in your textbook? There's a reason for question 1, question 2, even though it seems like it's the same thing. And that's because they changed something. You know, they add something in that might be put in an exam question to not necessarily make it any more difficult, but just change something. So, for instance, let's have a look at 2a. So it says x equals y plus 2, okay, and 3x minus 2y equals 9. So what have they changed, and why do you think they've changed it in that way? X equals instead of y equals. Do we?
Do we know?
No.
Why
You have to
can't
get
just-
X anyway, yeah?
Why
I'd like.
can't you just do the same thing? I don't understand what's the problem.
No problem. I'm just asking the question. Could we not just do the same thing,
Yeah.
only replace the X instead of the Y?
Right.
So I think the reason why they've done this is to let you know it does not have to be Y equals.
Yeah.
You don't have to start with Y equals. You can do X equals. So in this case, the X gets replaced with Y plus 2. So we have 3 lots of
5.
Y plus 2
Minus
minus 2Y equals 9.
Y.
That makes mucho sense.
Yeah, so you don't have to find X first. You find Y first if you like.
You can find P.
As Samir said, you've got to find them both eventually anyway. Okay? I'm not going to go any further with that one, but I did want to point out also B, same lines, but it says X equals minus 1 plus 5Y, and X equals 3 minus 5y. Okay? Again, it's just different because it's an x equals. Both of them are x equals rather than y equals. What's your first step?
You have you gotta equal it. 3 minus
The what, sir?
1 plus 5. Oh no, you just put negative 1 plus 5y equals 3 minus 5y.
Yeah, exactly. We do what we did right from the beginning. We just remember that we equate both sides. I've got x equals. I can make those two sides the same. They're the same value in the same way that y equals. Now the reason why they talk about this is people get into their head it has to be y equals. And it doesn't at all. Okay? So don't let it confuse you that it's x equals.
Sorry, it's just my leg is really like got something broken.
Okay. So don't let it confuse you that x equals can't happen, y equals is perfectly okay. Alright? I'll let you carry on.